Alright, so let's go into a little bit more detail about how we built some of these components. So we'll start with the instruction memory. Here what we have is essentially our inputs, or sorry, these are the outputs. These are essentially or actually wait, no, these are receivers. Yeah, these are the inputs. So here each wire corresponds to a different bit, and what we're doing is we're taking in each input to each bit and we're cascading it through a bunch of these little gates here, and these gates are essentially deciding through the vast array of possibilities and giving us an output at the end here. So we'll fly over to the final output after it cascades through all of these, and it's transmitted right here. Right, so what exactly is the instruction memory in this case? Well, if you go to the back, the instructions that it's testing for, essentially it's looking for in bit form, are encoded using these little levers here, which represent ones and zeros, ons and offs. And so we had to manually go through and input each of these, toggling them so that they're the correct instructions. And yeah, and so essentially we did that manually for the toggling about, I guess, yeah, that would be 8 times, but each thing has, so you can see, many number of bits. So here we're at 448 bits. If you keep going, you end up getting to around 128. So yeah, we'll just go all the way to the end here for fun. Whew, chunks are not loading. This thing is huge. Yeah, and here we are, 127, which is the 128th bit for this row, which is the top level, the top instruction. And now we're just going to jump down. Boom. Awesome. Alright, now we'll go into a little bit more detail about the ALU. As you can see here, this is the essentially an adding machine, a giant 8-bit adding machine for us. And it does also have the ability to tell if the things are equal. So this is basically a 8-bit full adder, as you can see here. And we decided to build parts of it underground. And yeah. Alright. And if you go over here, you'll see where the signals are being transmitted and also received. Each of these frequencies corresponds to some different connection. Essentially, wireless communication we found would be easier because, you know, having to manually wire these, especially when they're so spread out, would have been a total hassle. And since the red power, or I think the receiving, or yeah, this is definitely part of red power. This the mod allows for 5,000 different frequencies, so we found ourselves using quite a significant chunk of that, but it all worked out in the end. So as you can see, these look quite similar to the instruction memory over there. These are essentially the data memory hot dogs, and we have the inputs here being the bits that are transmitted from the essentially the decider, as you could call them, or the pancakes in the back. Each of the towers in the back corresponds to one of these hot dogs. So let's fly over there now. Whew, so big that chunks are still having trouble loading. It's amazing. Alright, so we start at frequency 200, but really this is frequency, or this is bit 0. Essentially, we're receiving the signal here from the actual other parts of the module. And so it comes in here. We use these bundled cables to nicely package up the 8 different bits that we're looking at. And we first manually made one of these layers and then decided to put it in MC-Edit and make one full tower of pancakes, as seen here. And then we cloned that 8 more times, as you can see off in the distance. And we had to go through and manually toggle each of these according to what we were getting. So yeah, after that, the bit is transmitted using this transmitter here to the hot dogs. And then that gets processed over and sent out.